All right, we are live. Welcome, everybody. So, here we are, episode 2 of Office Hours for Massdriver. Um, this is a monthly office hours that we host that allows our community, our users, random people on the internet to be able to ask us questions about Massdriver, about platform engineering, about DevOps. We're here to talk about that. Um, we'll also have our CEO, Corey, join us here in a little bit, where we're going to have just a casual discussion about artifacts, artifact definitions, how they work, how they were thought of in the first place. So he should be joining us here shortly. But so yeah, this is just a stream that we like to host at the beginning of every month, where if you have questions, please post them in the chat. This is an opportunity to talk to myself, other members of my team live to get answers to your questions. Um, Again, about Massdriver, about platform engineering, about DevOps, about tech, anything that you really want to discuss. We have an open office to do that. So feel free to pop in the chat, and I will just kind of hang out here. Corey O'Daniel, our CEO, should be joining us momentarily, and then we'll be able to dive into our discussion about artifacts. So, okay, we have a couple people watching the stream. How you guys doing? Wednesday, midweek, busy week. It's been super rainy here in San Diego. Um, Not sure what the weather is like where you guys are, but it is pouring rain outside. Pretty nice. Okay. So this week I'm going to be recording a new video, um, a video about making a custom artifact definition. So I'll be going through that. The video should be live either tomorrow or Friday, where I'm going to go through the process of um, kind of revealing a small custom bundle that I make that requires built that doesn't exist yet. I'm going to go through the process of building that artifact definition, and kind of showing the different layers of how that looks. And then I'll be publishing that artifact definition so that it's accessible within the Massdriver platform, and then consuming it with my custom bundle to have the downstream outputs that I require for my application. So stay tuned for that video coming. Should be releasing around Thursday or Friday. Let's see if I can get some EMCA music playing. How are you guys doing today? Studying some React. Nice. That's always fun. And I'm sorry. I'm sorry that you're studying React. That sounds painful, actually. Okay. So yeah, just to reiterate for anybody else that might have joined, episode 2 of Office Hours, we're just getting started with it. So Office Hours is an opportunity for our community members, our users, to interact with us, ask us live questions, get live answers. We'll talk about Massdriver, we'll talk about platform engineering, DevOps, whatever questions you want to shoot our way, we'll be happy to talk about and answer. We should be joined by our CEO, Corey, pretty soon. And today we're going to have a discussion about artifacts, kind of like where they came from, how they work, how artifact definitions work, and things like that. So we'll be able to have a discussion about that. And then at the end of the office hours, we're going to be posting this video, this recording, to our YouTube channel so that it's accessible from there too.
Yo.
Oh, hey.
I don't
What's
know if
up?
my audio. Hold on, I'm checking out my audio. I did a little desk revamp and nothing works.
Sounds great on my end.
Okay. Okie dokie. See
How's it going?
See how long these AirPods will work. How's that?
Oh, good. Oh, I see an echo. No.
Yeah, it's fun times over here. I love technology. It's not. No, I can't hear you at all. Hold on a second. It says they're on. Okay.
Test.
All right. Well, I can hear you from really far away. You're coming out of my computer speaker, which is a mile away. I'm not sure if you can hear me well. Can you hear me well?
Yep, I can hear you well.
Sweet. Sorry about that. I'll keep these in my ears. I don't know why. Maybe they'll turn out eventually. Oh my.
How's it going?
Artifacts.
Artifacts, yeah.
You want
How's
to
it
talk
going?
about artifacts? Doing good. I was just doing some tweeter stuff, so I was tweeting this out. But yeah, doing good otherwise. Got a bunch of sales calls today. Got one right after this, so I might clean up my office while we're here.
Nice.
Yeah, no, it's doing pretty good. Actually, I can do a little whiteboard session on what artifacts are and like how they work behind the scenes if you're interested. I'm not sure that you've actually seen some of the guts to it. Haven't practiced this, but it's also interesting because this is some of the stuff that we're going to be open sourcing this year, right? So we have a server internally called Gov, which manages state. It's a joke, Gov. So we're going to be open sourcing that, I think, for like right around PlatformCon this year. And what Gov is, it's effectively a way of controlling access to your state in Terraform. And so Gov actually works with any IAC tool, whether it's Helm, Pulumi, etc. And it's how our artifact system works. So effectively what an artifact is in Massdriver artifact definition is it's a contract between two different pieces of infrastructure as code, whether it's Helm, Terraform, etc. Right? And so if you're familiar with Terraform, you know that Terraform generates a giant pile of output after it runs, right?
Oh, yeah.
And so this is great. Like there's these things that you need to know, but like there's kind of a mixed concern there, right? So like as like the person working on it when you're deving, you're adding all sorts of stuff to output so you can have an idea of what happened, right? But that output is also input to other Terraform modules. Terraform is the closed source version of OpenTofu. Funny that we got a little OpenTofu emoji working there. So like when you're in Terraform or OpenTofu, you have this concept called remote state, which lets you, as like a downstream piece of infrastructure as code, pull information from an upstream. So if you have like a cluster or a database and that runs on a network, you have a network Terraform module, and then you have a database Terraform module. The database needs to know something about the network. And people get this stuff into your database configuration in a number of ways. Sometimes people just take it as a variable and you type it in, right?
Right. Yeah.
That's super prone to error, right? Like somebody makes a change to the VPC, a subnet's name changes, or some aspect of the subnet changes, but now you have this other Terraform module downstream that like you've hard coded a value into, or you've inputted a variable to it, right? And so now like there's a mismatch, right? If you told it the subnet to run on and that subnet has disappeared, this infrastructure as code module that holds your Terraform, I think I'm backwards on this screen. So if my upstream and downstream's backwards, I apologize. But effectively your database becomes broken at that point in time, right? Like the module no longer works, but you don't know it until you run it, right? And so there's this concept of remote state, which is, hey, instead of taking it as a variable to your module, I'll just reach in and grab something from this other state file. If we did that in code, you would think that was insane. Like that's just like reaching into a private function someplace else, right? And just like yanking the guts out of it. But that's what we do. Like that's how Terraform state works, right? But again, like
Crazy.
going back, it's this mixed concern. Like to me, as the person actively developing a module, the output is how I know different attributes about my infrastructure, but it's also going to be how downstream things access it. And so the concept of artifacts in Massdriver is a constrained, controlled view of that state. So instead of me saying, here is my network, or here is my database, and here's everything you need to know about it, readers, writers, subnets, security groups, yada, 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 all the stuff that I put in my output, that might not matter to my downstream. My downstream,
Right.
like an application, might just need my database credentials, right? My application doesn't care how many readers I have. My application doesn't care what the security group is that's placed around my database. What it cares about is how do I connect to Postgres? That's all your app
True.
cares about. It just needs credentials, right? And so an artifact in Massdriver is you saying there's a subset of this state that I want to share with other parts of my system. But like most importantly, there's a contract. So what I'm saying is my application's IAC and my database's IAC both agree what Postgres authentication looks like. And so it's up to my database to output Postgres, and it's up to my application to receive Postgres. And that's the only information that travels back and forth. I'm not sending subnet groups and all this other crazy stuff that might only matter to the operator. I'm just sending enough for the next piece of downstream to understand what's going on. But I can also have constrained control over that instead of giving you, and what I mean by that is like being able to say like this bundle, like, or sorry, this module, like the application module has access to it. Not everybody that has access to my state has it, right? So
Right. Yeah.
today, effectively the way your state works when you're doing remote state is you say, okay, you want to access the state of my database, here's everything. And here's also my S3 keys for getting to my state, which happens to be where all the rest of my state is, right? Like
Oh,
it's kind of this like security nightmare, but with artifacts, I'm able to say my chat application can access this Postgres credential. And that's the only piece of information it can get from state. It doesn't have access to my S3 bucket where all of my state lives. It has access to this one field. Um, so yeah, so that's one of the
I,
things we're going to do open source, and I can dive into it a little bit. I got a little whiteboard here.
I,
I can draw some
yeah,
stuff.
yeah, yeah. Let's do that in a second. What I'm curious of is when you and Chris and Dave came together and kind of like thought of Massdriver, built Massdriver. Did you guys have this idea of artifacts already in mind, or like where'd that come from?
Yeah, I mean, it came from Terraform remote state, right? And like what happens, it's really interesting because there's a bigger problem here, right? Like Terraform and OpenTofu, right? Like they've solved this problem of like I need to get some information from one module to another, right? But in solving it, it's created a bunch of other problems, right? So like the we just kind of talked about some of the security implications of it, but what's really interesting is everything that we do in the cloud cares about the layer below it, right? And it's funny when we think about our applications. Okay, I have an application. Let's say it's written in Go. Yeah, I package it up with Docker, and it can run anywhere. I can run Docker. It can run on a VM. It can run Kubernetes, ECS, Nomad, wherever, right? Maybe even throw it into a Lambda. But what's funny is like when you think about our applications, despite the runtime that they're sitting on, our applications themselves are getting smaller and the surface area of the cloud that they're using is getting larger, right? So if you think back like 15 years ago, I needed a background processor. I got a background job in my app. I'm coding all this stuff. I got crons, yada yada. And like today, you'll reach for an event queue. You'll reach for SNS,
Right.
SQS,
Yeah.
Kafka, right? Like we've started to shift that complexity of like these asynchronous tasks, these background jobs to event-driven systems, right? And so my application runs on Kubernetes, but has a dependency on Postgres and it has a dependency on Kafka. Like there's three things that I really depend on to get my application running, right? And so there's a lot of information you have to feed into your app. Now, what's funny is your applications also pass off information, right? So like internally in
Yeah.
Massdriver, we have our authorization server, and our authorization server needs to be able to handle MTLS information and host information over to any of the applications that do authorization, right? So even our applications have this metadata that we need to pass forward. What do you do outside of Terraform? Our applications are defined in Helm. Our applications might be defined in the serverless framework. Sorry if anybody uses the serverless framework and you just pounded your head on your desk, but yes, like right, like there's this information we need to project forward from our applications as well. And so like that's where the idea came from. Is like we saw this thing that existed in Terraform. It was really great for Terraform to Terraform, but as soon as you cross this threshold of okay, well, there's a database that I need access to. There's my application definition. Here's where it gets really funny is my application is actually two sets of IAC. It's the Terraform to make my IAM role, right?
Yeah.
And bind my IAM role to different policies. And then it is the Helm to deploy my application and assume that IAM role, right? So
Right.
kind of
Yeah.
have two layers of IAC. So I've got to route in some information for like binding the policies of the database to my role. I got to route the credentials from this database into my application, right? But now I also have to now route out host information from my authorization database to my application database, right? So like there's all this information that's going to get passed around. And the way we solve it today is copying and pasting some shit in the LastPass, or going and setting up maybe something like Console or Vault or AWS Secrets
Secret
Manager,
manager.
shove a
Yeah.
bunch of stuff into it, right? But the reality is like we just have these connections that we're kind of connecting stuff together no matter how we implement it, right? And so what we saw was there was this really great way of doing it in Terraform, but as soon as you stepped over to Helm or anything else, there wasn't an option. And as soon as you stepped over to something like Helm and you wanted to consume the outputs from Terraform, that also wasn't an option, right? Helm doesn't have the ability to read from Terraform remote state. And so the idea for artifacts was creating this kind of unified layer for IAC to be able to talk to other components. So Terraform can talk to Terraform with constraints. Terraform can talk to Helm. Helm can talk to Terraform. Helm can actually export information and pass it into Terraform with our artifact system. So that's one of the really nice things about it. So now if you're thinking of, okay, how does this work for me outside of Massdriver when you guys open source it, and you look at kind of all the stuff that you glue together in your pipelines, right? Okay, I've got some IAC ran, it pushed some stuff out to console. Somebody else is pulling something from console, right? All that glue, we're trying
Yeah.
to make that into a single service. So it's just like, okay, great. Terraform just stores its state, and Helm has the ability to pull Postgres credentials out of it. And now Helm will start up and read it, pull these credentials out of it. So that's kind of where the idea came from, was just like extending that functionality with a security minded approach, but also like kind of embracing some of the principles of software development, like pushing it down into operations, right? Between systems today, we have things like GraphQL or REST or Open API, right?
Right.
Or Swagger, right? We have these definitions between services, but we don't do that with infrastructure. We just say, oh, fuck, the Terraform output is great. That's great until me, again, mixed concerns. I'm the developer, I'm working. I'm like, I'm changing something about how this database IC module works. I called this output database URL, but it wasn't really the database URL. It's all the credentials. It's a map, username, the password, or username, the username, password, the
Yeah. The full
password, host.
string, connection string.
It's not really the URL so much as it's authentication. So now I changed the name of the field because it makes more sense to me. I just broke everything that uses this. And you know what's the best part about breaking everything that uses this? I have no idea. I don't know who's using
Yeah.
it. Like, who's pulling this field? I have no idea. There's no way for you to know that today, right? And so like that's one of the things that's a bit harrowing about Terraform and IAC is like the way that we start to glue these things together and get these systems that can truly automate a lot of our toil away. just present us with more problems. Great, I can connect these things. But if somebody that maintains this module changes a field name because it makes more sense to them when they're viewing information, it breaks everything that uses it. And you won't know until you try to use it. So now a developer 4 teams away who is receiving credentials from this database module to start his app, he deploys his app. Maybe he hasn't deployed in 3 weeks. Maybe it's a stable app, but they make a change today. They deploy, app crashes. Holy shit. What was it about my change that broke it? Now you're in Datadog, right? You're going through a bunch of stuff. I'm like, there's nothing that, like, this works in staging, like it works in my local machine. Like, why doesn't it work in prod? Because where we pulled the secrets from, the field name changed.
Right.
And
yeah.
that person didn't notice it there. I'm the one that's surfacing it now. Now I got to go to this person and be like, hey, you changed this field. Like, should I change the field that I'm receiving? What is the field name now? Like, I have to go change my Terraform, right? And so with Gov and some of the stuff we do with artifacts, like, it stops that from happening. When you change like a field name, the contract becomes invalidated. It's kind of, you almost think of it like an API call. Like, you're effectively making an API call to store the state, and it will cease and be like, this doesn't match what you've said. You've promised to give a field called database URL, which happens to not be structured like a database URL. That's your problem. But this is what you agreed on, right? And so now, as an ops person, you can start to do what we do in software. Okay, I need to make a forward compatible change. I'm going to add a second field called authentication that has the 4 keys underneath it, right? And
Yeah.
I'll put both now. This database URL one, like, I would love for it to go away, but this makes sense to me in output. I'm going to start calling it this, and I'm going to tell my users, like, hey, start using this field instead. The other one's deprecated, right? Like, we don't have a really good way of deprecating state. So it was kind of all those problems that we solve for 7+ years of using Terraform across a bunch of organizations. And as we started to think about, like, the system that we have that works across the IAC, like, how do we extend this same functionality but not extend all the pains that it's caused teams that are running Terraform and managing remote state?
Yeah. Makes sense.
Sorry,
yeah,
that was a big old bag of words.
I mean, it's helpful to understand how artifact definitions, or artifacts in general, how the artifact system works, because, and correct me if I'm wrong, but nobody else is doing this. Nobody else is close to doing it.
Yeah, I mean, I think I don't believe that people are. Like, there are concepts that are similar, right? So, like, Terraform Cloud has launched this concept of stacks, so you can kind of start connecting multiple IAC tools together, right? So it's the same thing, right? Like, our artifacts. I'm going to try to share my screen. I've actually never done this before, so, like, this might
Go for it.
become bonkers. So I'm going to share my whole screen, and then you have to let me know if this actually works on your side, because I won't be able to see anything anymore, I don't believe.
Should be good. Once you share your screen, just add it to the stage. I'll update our cameras as I need to.
Okay, dokie. Let's see if this works. I'm trying to do this Mac or iPad AirPlay thing, and I think it takes over my whole screen. I'm not sure if you guys will be able to see it or not. I'm gonna share my whole screen. Look at you guys can see the backstage for StreamYard. Pretty exciting. Let me know if you see. Did it work?
Yep.
You see an iPad?
No, I see your browser.
Damn it. Okay, that does not work. So it does not screen share your AirPlay. Let me figure out how to get this in here. Is there a whiteboard in here? No, there's cinema layout. There's this. That's pretty cool. Okay. What is the best way to get my iPad to show up here? I have an idea. Well, here we go. Duct tape and stuff together. Welcome to Ops Land. Okay, I got the idea.
So Corey's working on bringing this up again to reiterate for anybody else that's joined late. So this is Office Hours, episode 2, where we kind of sit here, we'll chat about a topic, we may bring some guest speakers on, but really this is an opportunity for everybody to ask questions to us live, get a live answer from a human, whether that's about Massdriver, whether that's about DevOps, whether that's about platform engineering, or eager to talk about anything that you want to learn more about. And this is what the office hours episodes are for. They are for you. And we're just happy to be here and kind of hang out, and we'll chat away as long as we need to. We have lots to talk about with artifacts today. Corey, our CEO, is joining us. He's going to be running us through what an artifact is from a high level, and then as soon as we can get a whiteboard up and running, he'll kind of break through the different components so we can learn how artifacts work.
Yeah, so I'm gonna have to go to my actual whiteboard. Okay, let's do this. I think this will work. And if it doesn't, well, you can shoot me out of a cannon. Okay, so there's a whiteboard.
There's a whiteboard, yes.
There's a whiteboard. Sweet.
See if I can. That's better.
Okie dokie. Let's see how long it takes for my screen to turn on. Okie doke.
You got the big screen whiteboard set up?
Oh yeah. I just I've got power issues in my office, so I have to either have my heater plugged in or my whiteboard plugged in.
The
So
sacrifice you make to educate everyone.
Oh my gosh, it's freezing in here, everybody. Okie dokie. Here we go. If anybody's considering getting a vibe board, I'd suggest getting the Google one instead. It's cool. It is the slowest thing in the world. I'm still waiting for it to start. It's like starting like one of those old like Pentium gateways. You got to hit the turbo button. I don't know if anybody's 100 years old like I am. Okay.
Here we go.
Boom. There we go. Okay. Nice. Yeah. So like, if for anybody who's familiar with Massdriver, these boxes might look a little familiar. If you're not familiar with Massdriver, I'm going to try to draw it in low fidelity. But like when you look at the canvas, you'll see that you've got these different bundles, what we call bundles. And so like, let's just kind of draw out like a real simple scenario. Got a VPC. We got maybe some compute here, like Kate's or something like that. Right. Also on our VPC, we might have, let's say, Postgres. And just for fun, we'll put RDS down here, right? And so, and then what's combining these two dependencies is, some cool app. This is maybe running in Helm. TF, Terraform, right? So like pretty basic, like 3-tier web application. You got a database, you got some compute, you got your application, maybe you got a cache in there, right? Now, what we refer to as artifacts are these things right here. Let me switch to red. You'll see these little controls in Massdriver that are these artifacts. And some of them will actually have two, right? So if you look at like our Aurora bundle, there's two outputs. There's the reader's authentication and the writer's authentication. So you can actually have like, okay, maybe I want to use Metabase just for running queries. I'll connect it to my readers. Maybe I'll connect my application to the writer's output. But these are effectively just outputs, right? Some output from running this IAC module. And your application may even have one as well. It might be like the API information for your app, right? So these are effectively contracts of us saying like, we are going to adhere to this output. I'm going to, as a VPC, actually, let me redraw this line really quick. There we go. As a VPC, I have one output. My output shares my CIDR range. Maybe it shares subnets and what those subnets are. They're public subnets, they're private subnets, right? Just enough information. It doesn't maybe share the name of the VPC. It doesn't share NAT gateways. It doesn't share peering information. It just says, hey, here's the subnets that you might need to schedule some stuff on. There's private ones and there's public ones. It's up to you downstream to figure out where you should go, right? And so what's actually happening in this connection in Massdriver, these two modules, when you execute them, they'll actually pull the output from this VPC. And the cool thing is this output, again, is a constrained view of your Terraform state. It's just a small snapshot that you want to share. It's effectively your contract as an operations person who understands how a VPC works. It's your contract for saying, like, this is how we run VPCs and share information in our organization. This is all you need to know. And one of the things that's a bit bizarre, like when you look at a lot of the modules on, let's say, the Terraform registry, is the number of outputs. Like, there is no contract there. Like, if you go look at the EKS module, for example, there's like 100 and something outputs. Like, it's almost unmanageable, right? And that's because you have 1,000 cooks in the kitchen, right? Everybody has their opinion of what that module should look like, right? Macy's is using it, Red Hat's using it, somebody at AWS is using it, 10 startups are using it, and they all need different pieces of information out of that module. And so you get to this really bloated idea of your inputs and outputs. Input everything, output everything, right? That's really hard to manage. I'm actually giving a talk on Terraform management, by the way, in early March at CodeBeam, if anybody's going to be there.
Oh, nice.
So what these outputs or artifacts do is they let you have this constrained view. So you can see, like, okay, I'm passing some subnet information here. And that helps the Postgres know, okay, I always schedule myself on internal or private subnets, right? Like, great, you just connect it. I don't have to think about passing information around, filling in a bunch of fields. All the networking stuff just gets applied to Postgres. And as the person who's even managing Postgres, I don't have to think about the network. I just think about what I need from a network. Well, I need private subnets. Great. There's a bag of private subnets that are going to come in across this connection. As we kind of move downstream to the application, this is where it gets really interesting. Is we're still offering these contracts, but what's funny is we tend to think of things in the cloud as very like cloud service oriented, not service oriented like architecture, right? So like we think of, oh, it's EKS, it's RDS Aurora, but it's not. Like, to our applications, it's not, right? Like, to our applications, whether you're using Active Record or Python Flask or Ecto or one of the cool new SQL tools in Nodeland, I don't know which one they're using this week, like, that RDS instance is Postgres, right? And so the way we design our artifacts is we design them to be agnostic of cloud and instead focus on developer intentions. So if you are a user of Massdriver and you see some of the artifact definitions that you can put out artifacts for, you'll see that we don't have an RDS artifact. We have a Postgres artifact, right? And the really cool thing about this is when you start to think about these, not like the cloud infrastructure, but the service that it provides, your applications start to be a bit more cloud native and cloud agnostic, right? So this application, and we have a bunch of these in our application examples repo, this application says that it needs something to run Docker on, and it needs Postgres. What's really cool is I can now connect it to Kubernetes, which gives some details on how to schedule a Docker container. And I can connect it to RDS, which gives some credentials on how to connect to Postgres. But if this was Azure Postgres Flexible Server and AKS, my app still works, right? And so, like, by living, like by thinking more about the service that you're consuming, not the service that is running that service, it gives you a bit more flexibility in how your applications work. And so what we'll have over here is, like, this artifact that's coming out might just be, maybe it's just Kate's credentials, right? Mm-hmm. And in Massdriver, we're able to use this line to automate your CI/CD, like how you're actually deploying your application. The Kubernetes cluster has projected some credentials that your application can now use for deploying itself. And now we'll use those credentials to place the application. Similarly, with these same artifacts, we're outputting the PG URL as a part of this payload. And now the application is starting up. And as the application starts, it receives this information across this connection, and you get secrets, right? Like, you don't have to go set up Vault, figure out how to do a bunch of glue to, like, bring this stuff together. Like, that's what these artifacts are doing. They're giving us a concrete contract definition between these two different components that are going to create some cloud infrastructure. and saying, I produce this thing and you're expecting this thing, and we have this contract that we know that it's always going to be correct. So the way that we actually do our artifacts behind the scene, they're structurally and nominally typed with validation. So what that means is before I connect or deploy Postgres, I know that this Postgres instance is going to make credentials, even though it doesn't exist yet. So what's really cool about this, we're using nominal typing. We're saying, I'm going to output Postgres information. That's our type. You can actually start to diagram things even though it's not provisioned yet, right? We're using this nominal type. I, as cool app, expect Postgres. This thing will provision a Postgres, right? Now I can start diagramming it. When the actual provisioning starts, then we switch to structural with validation. What that means is we're effectively enforcing the contract of this artifact. It's no longer just a name. It is now Postgres, which might contain credentials. It might contain whether or not SSL is enabled, right? It contains additional information so my application can understand how to connect to it with rich validation as well. And so what's really cool about that is that rich validation. We kind of do this all over Massdriver. We do this on the inputs or parameters when you're configuring something, but also on the artifacts, is it lets you have guarantees that don't exist in Helm or Terraform or even Pulumi, right? So now I can say my Postgres will only run on private subnets. And so now what's cool is, if you get out there and you start connecting some infrastructure together and you're deploying Postgres and somebody outputs a VPC to you and it outputs everything under the sun, and you just kind of say, okay, give me these 3 subnets and deploy. You deploy, whoops, I'm on a public subnet. Whoops. With the artifact definitions, you can actually say, these are private subnets. And now my thing that's consuming can say, I only accept private subnets. I don't accept public subnets. And so you can literally start to codify real powerful rules in your organization. I can say my Postgres databases will never run on a public subnet. And so if somebody connects it to a VPC that only emits public subnets, guess what? That Postgres will just fail to deploy, which is exactly what you want, right? Like you want somebody to go correct that VPC, not let me deploy something that's a little less secure.
So let me ask you, and apologies if I'm jumping ahead, but Postgres server is outputting a Postgres URL, Postgres credentials, whatever it is, and then the contract is made with my cool app Helm chart, so that value gets added in there. How does it pass through as an environment variable? Because my application code needs to consume those Postgres credentials to authenticate to my database. Can you talk about how that works within Massdriver 2?
Yeah, so we have something called dynamic configuration. I can switch over to some code in GitHub, but I can kind of scribble down some YAML real quick. So if you look in your YAML file for
you're kind of going
Massdriver,
off screen to the right a little bit. I don't know if you're able to pan the whiteboard to the left.
Hold on, I'm gonna put me in follow mode. Yeah, there we go.
Nice.
So if you look in your YAML file, you have this top level app key, and then underneath there you'll have a key called env. And this is, if I remember correctly, it's a map. And so what's really interesting is we have this concept in Massdriver called dynamic configuration. And what it effectively does is it lets you pull details out of your diagram using JQ expressions. So now what I can do is I can have a variable here called Postgres URL, right? That's going to be my environment variable name. Somebody might call it database URL, right? Like, it doesn't matter what you call this environment variable. What matters is where the information comes from. And so you can use these JQ expressions to do something like dot connections. So we have a couple different things that you can dig through when you're trying to do this dynamic configuration. We have params as a top level key, connections, and also secrets, which is like third-party managed secrets like Stripe keys and stuff like that. So you can actually pull information out of your parameters, which is what you fill in on the form, or your connections. And all these connections, all these artifacts right here have names. So like right here, like this field might be called my database. And so I can do things like connections.database.url. And that will use JQ to pull the URL field from the database object from the connections object on my graph, right? And so now what's really cool is secrets management is all handled completely behind the scenes. It's routed into your environment variables during provisioning. You didn't have to set up secrets. You didn't have to set up vault. You didn't have to do a bunch of glue between things. All of the credentials are injected into your runtime. They're not stored in some intermediary thing like LastPass waiting for you to copy and paste them. And you can also do like really powerful JQ expressions with this. So maybe your database just outputs a URL, but maybe you also want to take the database name from your parameters. Maybe right here in Cool App, you're able to set names for your database, like maybe chat prod, right? So the credentials come from here, but like the database that you're actually using, like the name of your schema is an application concern. You can actually kind of mix this stuff together. So I can say database URL plus database name. And I actually pull the credential information from the database, and then I can pull the database name from my configuration, right? So it's like, okay, now it ends up being host name, username at password, host name, port slash chat production. And you can do a lot of really interesting stuff with this. Like you can do additional concatenation, pretty much any JQ expression becomes valid here. And you can also do things like, let's say you want to do your Stripe key. We have our own third-party secret store, and these are always stored in secrets. So you can say secrets.stripe, and that will pull a secret out of our secret store for you and place it into your environment variables. So not really artifact related, just kind of showing the same functionality around here.
Mhm.
But so this is one of the powerful aspects of it, is being able to pluck this information. And that's one of the things that our Gov server that we're going to be open sourcing does for anything. So it just gives you a standard interface for saying, hey, I want the URL from this constrained view of Terraform state that we call database, right? And it might not be all my database networking and subgroups and policies. It might just be my actual database credentials. But now I can get that information directly over to Helm or to Plumi. It's really nice because it actually allows you to kind of talk between IAC tools, right? Like the reality is, even if you're a startup and everything's brand new and fresh and you don't have a ton of technical debt, you're going to end up with probably at least 2 IAC tools. You're going to end up with the thing that makes your networks and databases, Terraform, et cetera. And you're going to end up with something that manages your applications, whether that's Helm or the serverless framework or like SlagD's Next.js deployer. Like there's this other thing that does your applications IAC, and being able to talk between those transparently is really powerful. When you start thinking about bigger organizations, they've just got so much debt. They have a lot of tools, and moving from a world where, let's say your business has been up for 30 years and 15 years ago you used Ansible and you started to move to Chef 10 years ago, and now people are moving to Terraform. You could realistically envision a large company like an insurance company or a healthcare company possibly having 3 IAC tools that are in flight because they have so much software, they have so much legacy systems, right? So to be able to talk from Ansible to Terraform or vice versa becomes really powerful, right? Now that gives me a path to moving off of Ansible to something like Terraform, because I might be able to cross communicate between those 2 tools.
So do artifacts only are they only used to pass out credentials, or is there anything else that we can pass within our artifact system?
You can pass anything. And so, in the artifacts that we build, so we publish, not only do we publish a base set of bundles to get people moving quickly, we publish a bunch of artifacts in Massdriver. They're effectively us just thinking like how teams should essentially agree on what a network looks like or agree on what Postgres looks like. And these are just our opinions, right? We try to think of them from all the consulting we've done through all the companies that we've worked at, and what we've seen there. But you can kind of flex them and change them as you see fit. But for example, our Postgres one, allows you to, or sorry, let's go to the Kubernetes one. The Kubernetes one passes IAM information forward. It passes Kubernetes authentication details forward. So we'll see when you look at ours is we actually have a little bit of a mix where we pass the things that are very application oriented, like the credentials, but we'll also, or sorry, service oriented, like it's Kubernetes credentials, but we'll also pass like cloud specific stuff as well, right? Because the reality is like, I might want to connect this Kubernetes cluster to my application, but I might also want to connect this Kubernetes cluster. I don't know, maybe AWS makes an Athena integration with Kubernetes that can do anomaly detection on your Kubernetes logs automatically, right? And okay, I want to add an Athena bundle and then just connect it to my Kubernetes cluster, right? Well, these artifacts can also emit cloud specific information. So you'll see that we do pass things like the ARN of the Kubernetes cluster, right? Why is that important? Well, in the OIDC stuff for AWS, like you need the ARN of the cluster to be able to figure out how to do OIDC for AWS auth. So you can kind of pass anything you want, and we structure these internally as JSON schemas. Let me pop one open here really quick.
Yeah, let's go through one.
Whoops. Perfect. If I could do, if there were two things I could do in my life, it would be rename organizations to org in our code base and rename artifact definitions to contracts. So we publish all of our artifact definitions in Massdriver, and then we open source them as well. So you can actually open pull requests against our definitions to redesign them. And you can see that we kind of lay them out here. So we try to dry some of these up. It's JSON schema, so they can get really big. We try to dry them up, break them down. So we have them kind of separated here. I'll show you the top level artifacts in a second. But yeah, we kind of break them down a bit. So if I go into artifacts here, like here's all the major ones that you'll see when you're using Massdriver. So what does an API? What's that?
Could you zoom in a little bit? Yeah.
Yeah. So like here is how you should pass path information from API gateway. Here is how you pass the REST API information from API gateway, Dynamo streams and tables, Lambda, Azure, Databricks, et cetera, et cetera. So if you're ever using Massdriver and you're thinking, oh, there's this piece of information I wish existed in my artifact, you can open a pull request here, or you can actually just take this definition and you can use the Massdriver CLI to publish your own. So you could say like, Massdriver publish artifact definition, Foo Corporation, Azure blob, and you can customize it however you see fit. So what I'm gonna do is kind of look at, you see we've even modeled like environment variables, like what does an environment file look like if you wanted to be able to emit one of those from an application. But here is Kubernetes cluster. So you see that it's not ECS, it's not AKS, it's not bare metal, it's just Kubernetes. And so this config file, the artifacts, like not all of this will be in Gov. Some of it will be in Gov. Some of it doesn't make sense, but these artifacts also allow you to control a lot of how Massdriver itself behaves. So almost everything about the platform is customizable. So you'll see like right up here at the top, there is an export option and download button. So this is how you customize Massdriver to let you download Kubernetes credentials from your cluster. So like, let's say you needed to remote into your cluster, manage something, you need to download it really quick. This lets you set the label, set the file format. This right here is a base 64 encoded definition of like what the template actually looks like for rendering the credentials. You can also see like this actually changes the label in the UI. So you can actually add your own artifacts to Massdriver, including credentials. So, a lot of people see the platform today and they're like, oh, you only support all three clouds. No, we actually support whatever functionality you add. So if you wanted to add support for Databricks, you could push up a Databricks artifact. The really cool things about artifacts is not only are they the way that we talk between pieces of infrastructure, it's also how we talk to your cloud. So by publishing an artifact definition, you can actually extend the functionality and cloud support of Massdriver. So they're all kind of one and the same. So when we come down to the actual, sorry, was that a question?
No, you're good.
So we come down to the definition again. This is all just JSON schema. So if you've done a bunch of stuff in API gateway or Kubernetes, you've probably seen JSON schema before. You can make these as strict or as lenient as you want. But the first thing you'll see is we require a field called authentication. So this is a part of our contract. You're always going to receive an authentication object from a Kubernetes cluster. And we also have an optional infrastructure side, which lets you pass over cloud infrastructure information. So, and you can see this is a one of. So if this is present, which it probably won't be on bare metal, you will either receive AWS EKS information, Azure AKS, or GCP infrastructure information. And you can kind of go over to the types folder and see like what cloud infrastructure metadata comes through with this. But the important part for the application is the authentication here. And you can see that there's two keys. There's a cluster and a user. So this is going to give you certificate authority data, a server host name, the user token to connect. And so if you're familiar with Kubernetes, like you probably recognize all these fields from a kube config. That's effectively what it's sending down as a kube config that your application can use to deploy and manage itself. And then all artifacts in Massdriver have two top level keys. There's data, which is required. That's the actual information that's going to be passed. We consider everything in the data field to be confidential. So all that is stored in an envelope encryption system, encrypted in flight, encrypted at rest, and encrypted per row in a database. Everything on the spec side is effectively stuff that you don't want to treat as secrets. It's specs about your system. So in Massdriver, when you go into your artifacts dashboard, this is the information that it will show. You can kind of think of it as extremely rich labels. So here we will, if it's AWS, we'll provide some AWS specific information, like the region that it's in, which is always important to know. Azure, GCP, similar. If it's Kubernetes, we might, like Kubernetes here being just general Kubernetes cluster, we might output
the version.
Yeah, version number, maybe like the address of the instance. So just stuff that you would actually want to be visible in the UI, effectively.
Makes sense.
Yeah.
Sweet. Well, we have about 7 minutes left. If there's anything that you wanted to cover within artifacts that we haven't already. If not, we can wrap up.
Yeah, I mean, that's pretty much them in a nutshell. I mean, they're a very powerful tool in the platform, and I'm really excited about getting Gov published. I think it's going to be really powerful just for the community to be able to kind of start having a bit more security and control around what you share between teams, right? I mean, when you think about the APIs between your teams, like bigger companies just have straight up networking teams, right? Like, and there's networking information they want to share, there's networking information they don't want to share, right? You have teams that just manage compute, right? Like, I mean, I feel like in the startup world, we tend to think of DevOps as this pile of responsibilities a developer does in between them shipping business value, which is like an unfortunately shitty reality, but also definition of DevOps. But in bigger organizations, they very much still have silos between teams, right? And if they can use this software that we're open sourcing to make those silos like APIs between those teams, like malleable layers where our networking team can say, hey, we're going to manage all of our networks using Ansible still, and we need to get you this information, but it sucks to copy and paste it or to Slack it to you. Like, here's this global store of state. Like, you can read from our Ansible through it, right? And if you're in Terraform, it just looks like remote state to you, right? If you're in Helm, it effectively comes through as a JSON file that you can pipe into your Helm install script, right?
Yep.
So different ways of getting it into different IAC tools, depending on whether or not like it actually has a runtime or if it's just generating, JSON files that it blobs a cluster. But I think that the stuff that we're building here is going to be really beneficial for. Sorry, I'm looking at the whiteboard over here. I think it's going to be really beneficial for these teams that are still trying to figure out like, how do we do DevOps? Like, how do we tear down these barriers between us, right? Or we can just tear down the barriers, but like, the problem with that is you get pure chaos, right? So how do we keep the barriers there? Like, focus on our expertises on either side of it, but have an effective mechanism for collaborating across that, right? And if I can say, I'm going to use my tools and we're all going to speak the same language, and we're going to give each other contracts to like guarantee like this is the way that these things come out, like that starts to really decouple the teams. Great, you're using
Yeah.
Ansible, I'm using Terraform, and the team that's deploying applications is using the serverless framework. It doesn't matter to me, right? Like I'm going to output some information. You can pull stuff for the serverless framework from our Gov state store. So
That I mean that topic of sharing information across IAC tooling was a consistent like oh shit moment at reInvent.
yeah,
Every single time somebody was described the process, it was like their minds were totally blown about the possibilities that are now open to them by using something like the artifact system within Massdriver, which was super cool to see.
yeah. I mean, it's crazy to think like the way that we share this stuff today between IAC tools is like, I mean, right? Like most companies, I'm sure there's a couple of people out there that are a bit more strict about this, but most companies dump all of their Terraform state into the same S3 bucket. Like, right? It's one S3 bucket. There's a
Yeah,
directory in there for every invocation of your module, right? In every environment. And so when you start sharing that remote state, you're sharing the entire thing, right? Like, I mean, it starts to be
yeah,
freaky to think about, right? It's Terraform, so it can execute just about anything. Okay, so you've given me credentials to access all state. You don't trust me, right? Like you shouldn't trust me. Like we should have zero trust. Like you don't know what's in my module that I just grabbed out of the Terraform registry. It could be a null resource that just deletes VPCs. Like we have no idea, right? Until we run it in
right.
prod. And then you still really don't have any idea because you're taking a dependency for no reason. Sorry, that's a whole other rant. Come to my talk at code game for that one. But um, so you're kind of giving full access to that S3 bucket to anybody that needs to read it, right? And so like there's
Yeah,
nothing that stops me at that point in time from having a null resource that takes every file out of that bucket and sends it to some HTTP endpoint. Now I've got your database credentials, right? There's a lot of trust in like remote state and Terraform. Like unless you break up every single state into its own bucket, which is tedious because you have to manage those buckets,
yeah,
right? You can manage the credentials for those buckets, right? So you can do that, but you're putting an additional management burden on you, right? Like why can't we have a constrained view? How do I revoke your access to one field without revoking your access to everything? Right. And that's kind of some of the problems that we're trying to solve here is saying like you get access to this one field in the state. That's all you need to run your application. And it's a grant. It ends up coming through as a JOT or a JWT. I can revoke it. It has an expiry time on it, right? I can say this is going to be valid for 90 days. You're going to need another one after 90 days. Great. That's something in your CI pipeline. It halts. It's like your key's expired. I give you a new one. Or I revoke it if we find out somebody has compromised your code base, right? Great.
yeah.
They've never had access to all of our state. We know the one field that they have had access to, and I revoked it. Now we can go and create new credentials for that Postgres database, but I don't have to worry about, oh, did they get our Mongo credentials too? Right?
Right.
Like
Yeah.
that is a talk about blast radius and Terraform, like that, like sharing your state. Woo, especially if files have write access to that state bucket. Oh, that's a dangerous one. Yeah. Nice. Well, I have to bounce. I have to go to a sales call, and I'm apparently going to walk into it with this haircut. So hopefully the guy's got a sense of humor.
Well, thank you so much for joining us and talking to us about artifacts.
Yeah, it
That
was
was
fun.
super
I hope,
helpful.
hope everybody found it interesting, and the people that just showed up at the end. Uh, we'll
Watch the
post this.
video.
Yeah, we'll post the video here in a bit.
All
Awesome,
right.
dude.
Thanks,
See
Cordy.
you later.
Thanks, Cordy. See you around.
Bye.
All right. Well, I think that about concludes our episode for office hours of this month. We will host episode 3 the first Wednesday of March, so stay tuned for that. I will go ahead and add this resources tab here. So if anybody's interested about Massdriver, hasn't had a chance to check it out yet, these are resources that you can consume to be able to find out more information. Again, we're going to upload this video about artifacts onto our YouTube channel. We'll post it on our social media links if you want to review them. But thank you, everybody who watched and joined us. And I'm looking forward to seeing you on the next one. See ya.